So in this video, we're going to define gas pressure. Let's start by taking the pressure and talking about what pressure is. Pressure, mathematically, is given with this symbol P, and it is simply the force, which is a push, divided by the area that that push is happening on. So for example, if you take your foot and you step on someone with a force F, right? And then you imagine that you take and you're standing on an ice skate and you step on someone's foot with a force F. In both cases, the force is the same, yet one of them would hurt much worse than the other. Of course, the figure skate one, this would hurt much worse because your area at which the force is applied is much less. So here's your shoe. That's a much bigger area. The force can spread out and it doesn't hurt as much. Well, when we look at a gas, when we talk about gas, if we have a container like this, we've got particles of gas inside. Some, they're bouncing randomly. Some are bouncing against the wall here and here and here and here. They're exerting a force, and that force is occurring over the area of the container. And so there is a pressure inside of that container due to the gas. When we talk about pressure, gas pressure, one of the types of pressure that comes into play a lot is atmospheric pressure. If you look up right now and you see nothing, there's actually a countless number of particles bouncing around crazily right on top of you, bouncing off you right at this minute. And they create a pressure that is known as atmospheric pressure. The instrument used to measure atmospheric pressure is right here. This is known as a barometer. And if you watch the news, they might talk about the barometric pressure is such and such. A barometer is simply a glass tube that's been evacuated. So they first take all the air out, and then they set the empty glass tube into a container of mercury. The atmosphere pushes down on the mercury, which then pushes it up into the tube. The higher the mercury goes, the higher the pressure is of the atmosphere that particular day. What is atmospheric pressure useful for? It's very good for predicting weather changes. The pressure will change, either become high or low, right before a major weather change. So if a storm is coming, the pressure will change. If a tornado is coming, the pressure will change. And so meteorologists can use that to determine and to some extent predict the weather. Now, atmospheric pressure, has some different units. So the most common, or the one that you'll see a lot, is, I should write this as standard pressure. So standard atmospheric pressure, Standard atmospheric pressure would be 760 millimeters of mercury. And that means on a normal day, the atmosphere is able to push the mercury up the tube 760 millimeters, or about 3/4 of a meter stick. There are some other units that are equivalent to this. One of them is this, 101.3, and then kilo, and then pascals. So this is known as kPa. So 101.3 kilopascals, and this is also equal to something called an atmosphere, 1 atmosphere. So these are the three main units for pressure: millimeters of mercury, kilopascals, and atmospheres. And they have different relationships to each other, but these are equal. It's standard atmospheric pressure. These are the three values for each unit of pressure. So how is gas pressure measured if you don't want to know the pressure of the atmosphere, the gas in the atmosphere, but let's just say we want to know the pressure inside this container, or the pressure inside this container. Well, now we use an instrument called a manometer. And what a manometer measures is the pressure of the gas inside the container relative to atmospheric pressure. And so you can see that, for example, this gas must have a pressure less than the atmosphere, because the atmosphere pushes the column of mercury down more than this can push down, and the difference in height will tell you the pressure. So for example, if we know that this difference in height is 100 millimeters, and we know that the standard atmospheric pressure we saw was, yeah, come on in. And so if the manometer, or if this difference here is 100, let's say 100 millimeters of mercury, and we know atmospheric pressure is 760 millimeters, then we know that the pressure here must be 100 millimeters less than this pressure. So then we can calculate this pressure to be 660 millimeters of mercury. And this is how gas pressures are calculated. Whoops.